All right, thank you again once more for joining in. My name is Philippe Ozil. I'm lead developer advantage at Salesforce, and today I'm replacing my colleague René Winkelmeyer, who was originally scheduled to present this presentation to you. Unfortunately, he's not able to join, so I'll be your speaker for today. Today, I'm going to talk to you about web components at enterprise scale, and this is in the context of a CodeMotion shared webinar. Before I jump into my presentation, I have to remind you that we are a publicly traded company, and so please make your purchasing decisions based on what is commercially available in the product. Now, I will not talk too much about forward-looking statements or features that are not available, so we should be safe from that. That being said, today I'm going to talk about three things. First of all, I'm going to do a sort of overview about web components. So some of you may discover them, others will rediscover them from another angle. Then I'll talk about how we can bring those to an enterprise scale. And I'll finish with a demonstration of how we've done that with something called Lightning Web Components. So first of all, let's start to discover web components. This story starts in 2014, and we're going to do a little time machine here and roll back a few years ago. So in 2014, we had a bunch of web standards. This was the time where we have ECMAScript number 5, and really there were just a few things that are available as standard. So at that time, what the industry did is that we all worked with framework abstractions. And this was the time where we had jQuery, the first Angular, all of that. And what these framework abstractions did was essentially bring a lot of additional functionalities to expand the use of web standards. Things like data service to provide access to backend data, also custom UI components with templating engines or rendering optimizations, and certain types of language extensions for things that were not yet supported. Also, these frameworks also try to close the gap between the different browser vendors so that it will more or less be a coherent experience across different browsers. This required a lot of work, and at that point, we could say that framework was becoming the language. So, meaning you had to learn a specific framework, and you were actually trying to solve pretty common problems, but in different approaches in different ways. So each framework has its own approach and its own language to deal with that. And as a matter of fact, these components that you'll be creating with your different frameworks would not be interoperable. For example, if you were doing something with jQuery, you could not port that to Angular or to React. And what that meant is that you had to be highly specialized in each of these frameworks. And once you knew one of these frameworks, well, what you had invested in terms of knowledge would not be transferable to another framework if you had to switch technologies along the course. So you had to relearn everything. And that meant that resources were pretty hard to find, especially if you wanted to hire web developers at that point. You were having to figure out very specialized resources, and the amount of those resources what meant the success or the failure of a particular framework. Now, this also had a cost. All of these framework abstractions were written in JavaScript, and as you may not know or not, JavaScript is far less performant when it's run in the browser compared to native code that is run on the browser. So that's going to be a major turning point. The adoption of standard will actually help us to improve speed and performance for custom user interfaces. Now, 2014 was the turn of history in terms of web standards. Web standard had become sort of stable across the last 15 or 20 years, and starting from 2000 to nearly 2014, there wasn't much happening on the web standard scene. But starting from 2014 and up till now, there's been a rebirth of web standards. And the two major organizations or consortiums that rule web standards, namely W3C and ECMAScript TC39 for the JavaScript standard, just met again and actually really discussed a whole new range of standards, and that's allowed us to see a lot of innovation on this particular sphere. With that, we can now see a different landscape for standards, and this allows us to compare the two types of web stacks we had across time. So 2014, as I mentioned earlier, there was a lot of work that was performed by front-end frameworks. But with the arrival of an expansion of web standards in 2019, we have a very different landscape now. Namely, the importance of web standard has really increased, and we have things like web components, template, custom elements, shadow DOM, etc., which are all part of this new JavaScript ecosystem, which allow us to do way more of the things that were actually done earlier by framework abstractions. And with that current stack trace, we have benefits from a lot of more native code running in the browser compared to what we had in 2014. This brings additional performance, and this also lets the framework focus on their core added value, namely specialized services, data services, and UI components. So with that, we can see really a turning point in how we use standards. Now, how do we apply these standards, and namely web components, to go for enterprise scale? Well, first you have to think about the challenges that enterprise scale offer or impose. One of the key things is that when something goes enterprise scale, it has to be performant. So it has to go fast, but it also have a lot of additional constraints that are tied to it. Backward compatibility is probably one of the strictest requirements for enterprise scale. If you create something one day, you want to make sure that everybody who runs on your enterprise software are able to port that thing and make it evolve safely forward. So safe evolution and backward compatibility are two key aspects of how you rule the life cycle of enterprise scale software. But you also have to take care about your users. And your users, when they are working in an enterprise environment, have a whole variety of different types of hardware. And for example, we also have different browser supports. So often you'll see that when you're targeting large corporations, they have really old machines and really old versions of browsers. And so you have to include legacy support in your requirements from the start. You also have to deal with the fact that when you're working at enterprise scale, generally you do not necessarily own the entire code base of your projects. So that means that you have to have a certain modularity and some sort of versioning, because you have multiple software vendors that will contribute to your code base, and you need to be able to deal with those dependency in a modular invention way. And these are part of the challenges we have to address when we go for enterprise scale. So how are we doing all of that? Well, take the picture that we had earlier about the web component, the web standard, state in 2019. Well, we've turned that into something called Lightning Web Component, and we've replaced these framework abstractions with specific features. And I'm going to detail those in the next slide. So what we created here is our own framework that sits on top of web components and their standards, and that allows us to use them in a very simple and efficient way. And we provide access to the Salesforce platform on top of that. So there are three main things that we'll provide: lockup, which is for security; data service, which is for interaction with our backend data; and base components, which will help us to create custom user interfaces. Now, you could wonder, why is that yet another framework? Well, this framework is really built with a specific intent, and if I'm coding the architects behind this framework, is we want it to eventually disappear. And the idea is that the framework, instead of growing like most web frameworks do, is intended to shrink with time. So we're going to remove a lot of things from it as web standards evolve. Let's take, for example, legacy browser support. So one of the browsers we have to support from day-to-day basis is called IE 11 or Internet Explorer 11. And that browser is still accountable for a large portion of the web audience. And especially in large corporations, we have to support that. So what we had to do with web components and Lightning Web Components was to actually bring all browsers to the same level. And to do that, we use polyfills. So that's JavaScript implementation of web standards for browsers that don't support those web standards yet. One of these web standards was something called the shadow DOM, the fact that you can have sub DOM elements, some DOM tree elements. And so what we have with IE 11 is that we had to recreate those back those standards by providing polyfills. And what we're going to do next is that we're going to remove those polyfills as the framework evolves and now as these browsers, legacy browsers, become retired. And so in the end, the framework will shrink and we'll have just native code from the standards. And this is how we envision the future. Now, to do that, we've taken a very modular approach. And what we did first was to work on an open source implementation of a framework that is absolutely not tied to the Salesforce platform. So what we created first, and we only recently released that, is an open source version of a framework, which is a standalone front-end framework. This is called Lightning Web Component Open Source. Now, because we had to bring that into an enterprise scale ecosystem, we did a bit of work to integrate that with the Salesforce platform, and this is the result of our work, what is called Lightning Web Components. So we've provided a range of services and a deep integration with this platform to allow our users to really leverage this framework in the most efficient and the most simplest way. And I'm going to talk about 3 of these key aspects that we've provided here. The first one is something called Lightning Locker. And this is essentially the security architecture for our platform. And what we're doing here is adding some security to the web APIs. One of the first things that we do here with Lightning Locker is enforce DOM access containment. If you know a bit about web components or the DOM tree, you'll see that once you're inside the DOM tree, you have access potentially to the entirety of the web page that you're running in. So when you have, for example, different vendors that contribute different components on a single page, vendors could have access to other part of the page and could read information that is not being edited in their own components. So what Lightning Locker service does is that it enforces this DOM access containment, and it enforces people to only have access to their own part of the DOM. So every component has access to its own component and its children. And what we did also with Lightning Locker service is that we introduced something called namespacing. When you work on a large and complex project, you have to basically isolate certain dependencies in something called namespaces. This concept is not new. It's something that existed before, like for example, Java. In Java, you have something called packages, and you can restrict the access of information between different packages. So if you have a vendor which does package A, maybe he doesn't have access to package B, for example. And so JavaScript does not have this equivalent. But when you're working on enterprise scale, you have multiple vendors, and again, you want to put some barriers as to what kind of information is available between those different vendors. And what we did here is intentionally introduce the concept of namespacing for JavaScript, having this Locker service enforce data access or component access. Another thing that this Locker service does is that it secures certain DOM APIs like window, document, or element by providing secure wrappers. So we have objects which mimics the base APIs and that secures them by restricting certain access. So for example, when you're inside a component, you cannot have access to the entire document. You only have access to certain parts of the document you're running in. This is how we enforce security on different levels. Another thing that we provide is something called Lightning Data Service. And this is how we simplify and make the effort to integrate with Salesforce data really painless. So when you have a complex platform with a lot of different endpoints and a lot of different APIs that you can call, you want to make sure that these calls are made in a very simplest manner so that there's not a lot of boilerplate code. And that's what this Lightning Data Service does. It simplifies the code you have to write to access to Salesforce data. Not only that, but it also works also on security side of things. When you work on an enterprise solution, you have a lot of different users, a lot of different objects and fields, but you have also a complex matrix of permissions for these objects and fields. And so what the Lightning Data Service does is that it makes sure that you can only see data from the right with the right permissions. One of the last thing Lightning Data Service does is that it provides efficient client and server caching. So caching can be quite complex, and what the service does is that it takes care of you of applying server caching, but also client caching with local storage. And this is done in totally transparent way so that you don't have to worry about learning how to deal with that. Finally, the last key service that Lightning Web Component provide is something called Lightning-based components. And what we provide here to our users is it's a library of built-in configurable components. There are more than 200 components that they can leverage, which are ready-made and have been just recently open source. So the idea is that you have this library, you can pick from these components and you can deploy them easily. Now, this is the theory. Let's now have a look at how these Lightning Web Components work in practice. So I'm going to switch now to a demonstration, but I will show you how you can configure, code, test, build, and deploy these web components. In order to show you this demonstration, I'm going to work with something called a sample gallery. What we're providing here is a set of different sample projects that are freely available and open source, which show how to create applications on the Salesforce platform. And one of the projects I'm going to show you today is called Recipes. This is basically a collection of small, easy to use and easy to digest code samples, which are based on maximum 39 of codes and that show very simple use cases. So I'm going to start with that and we'll explore this recipes. But before I jump into a more complex project, I'm going to show you very quickly how you create a new project. So what we provide here as a starting point is a command line interface for a new user to create projects. So I'm going to create a new project with something called SFDX or Salesforce DX, and I'm going to create a new project. Oops. With that command, I'm creating a new project called demo. This creates for me the structure that is required for this new project, and I'm going to open that demo project with our official IDE. So you may have recognized here Visual Studio Code, which is one of the IDEs that we support by default. There are other IDEs that are provided by our partners, but I'm going to work with this one. And the way it works is that this is what we are seeing here is a default IDE, but what we have done here is that we have added a couple of extensions to it to support Salesforce environment. And namely, we have something called the Salesforce extension pack here, which wraps different extensions for us, which do code completion, syntax verification, and remote code deployment. So we're going to use features from this extension pack to deploy our components. So let's take a look now at the structure of the project. All of our code is stored, our source code is deployed in Force app, and our Lightning Web components are going to be placed into this LWC folder. You'll see that our project can support multiple resource types. In this particular example, I'm just going to focus on Lightning Web components. So if we're going to create a new project, a new component, sorry, you could say I'm going to create a component called hello here, and this will create for me some sample files. Now we have now a new component called hello, and what we did here with the quick wizard is that we created a couple of files. I'm going to start with the HTML HTML component here. And this is how we could create a component. So the first thing that we have to see in the HTML is that it's wrapped by a template tag. And the template tag is something that is absolutely standard. This is part of the HTML5 specification. This is a fragment or a custom element that we're going to use to create our project. So if I just now add some standard HTML, hello code motion, I can save that and I'll be able to push that. Now, along with this HTML template, we have also some JavaScript which has been generated. And notice that we're using modules from ECMAScript 6, and we're actually also creating a class here. the class here match the name of our component, it's called hello. It also extends Lightning element, which has been imported from Lightning Web Components here. And this is the basic for doing all the syntactic sugar to put in place the web standard. So this takes care of registering the web components and making sure that it's available as a custom element. Later on, if I want to reuse this hello component, I can use a custom tag hello to integrate it into my application. So this is how we create a blank new product. Let's now switch to something a bit more advanced. So I'm going to jump now to another example now. I'm going to switch to recipes application. What we're looking now is the recipes application, which is deployed on the Salesforce platform. So the Salesforce platform is just here. We have a lot of other applications that are available, but I'm just going to focus on recipes for now. This is the first tab here where we have variations of the hello world example. And the one that I just wrote before is an equivalent of this one, the component that we're seeing in Visual Studio Code. Now, what I'm going to look at now is something a bit more advanced with conditional rendering or binding. So by looking at one of these components, for example, hello binding here, we're going to see some additional concepts. So now that I'm opening hello binding, we're going to see how this goes. So here, when we look at the template of our component, we still have the template wrapper tag, but we have also custom elements. And Lightning cart here is declared as part of the Lightning-based components. So we provide some reusable and configurable components here for our users so that they don't have to reinvent everything. And this has certain properties, and then we can inject standard HTML in those. Now, this component that you saw is just some text with an input, which is customized to be a Lightning input with some values. But what this does is that it displays the value of its text here with a template. And as we change the input text, the value of hello will be updated. Let's have a look at how this is implemented. Switching now to the JavaScript file here, we still have the same structure as we saw before with a hello binding class that extends the Lightning element, but now we have some additional concepts. We have here something called a decorator, which is also part of the web element standards. And decorators allow us to add special properties to a class attribute here. The attract decorator in this instance allow us to make a property reactive. What this means is that if we change the value of greeting, this will re-render our template with the new value. So what we do on this particular line is that we set an initial value to our property here, greeting world, and then we have declared also later on a function here called handle change. And this is an event handler that reacts to change on the input. So if the input changed, we fire this handle change function with a new value, with an event, which is the change event. And with that, we're able to update the value of our greeting property. So if I go back to the template, we had the onChange change handler here, which is mapped to our function here. So each time we change the value of the input, it fires the onChange function, which allow us to update the greeting value, which will re-render the component to the latest value. Let's see that now. So if I say hello code motion now, you can see that the code is updated as I type above. This is really a simple example. Now, this is something that works both in the open source version of the framework and on the Salesforce platform of the version of the framework. I'm now going to switch to something that is a bit more advanced, but is also specific to the Salesforce integration. So we're going to move now to the second tab here called Apex. Apex is our backend language. It's pretty similar to Java, but it's made safe to operate in a multi-tenant environment. And what it does is that it lets us do data manipulation, among other things, and backend processing. So I'm going to look now at one of these other recipes, and this one in particular apex wire method with param. This allows us to fetch a list of records that are stored inside the Salesforce platform and filter on them. So for example, in the search bar here, if I try to filter on Amy, for example, this will filter my list of data accordingly. So what I'm going to do now is I'm going to look at the implementation of this particular um, component here, and we're going to see how we tie or use our front-end logic with some backend data. Jumping back to Visual Studio Code, let's have a look at this component. We'll start with the HTML. So the HTML is wrapped again in the Lightning card, which does the frame around it. We have our input for doing the search here, and we have conditional rendering to display results. So if we have some data in contacts, we're going to list them by doing an iteration and adding paragraphs to list our contact names. So what is important here is that we have contacts, which is a list of contacts, and we have a search key here, which is being updated as we change our input. And what we want to do here is call an apex function to get the list of contacts filtered with this search key. So I'm going to jump now to the JavaScript that is tied to this particular component. And what you see here is a slightly more advanced component with a couple of extra things. So we still have the attract decorator here, which allows us to have a reactive property. But we have a new decorator here called @wire. @wire is what we use to call backend functions, and this is something that is really helpful because it allows us to minimize the amount of code we have to write to access backend functions. Now, before I jump into the configuration of @wire here, let me show you another thing here. We have another import here, which is importing find contacts, and this is importing a module that has been automatically generated by us by the Lightning Data Service. Sorry, I think my mic just cut. All right, so what we have here is a link to the backend here. This is allowing us to automatically generate sample code to let us write access to backend logic. So we have some Apex calling the contact controller class and the find contact method. Turns out if I go over here, we have a custom in our Apex code, we have a contact controller here with that particular method defined. So I'm going to jump to that and we're going to look at it. It's just here, and this is what is being called on the backend. So the backend has access to data, and here we have a language which is pretty similar to SQL. It's called SOQL, which is the Salesforce specific implementation of SQL, and this is what allows us to retrieve data. So we call this particular method by providing the search key. It will filter a list of contacts and return certain attributes on this contact list and return that to the client. Now, with this particular method is exposed to the client because we have annotated it with or are enabled. And we have also enabled caching to this particular method by specifying a cacheable field true. Now that this method is exposed, what the platform did is that it's generated for us a JavaScript modules that lets us access this thing here. So this way we can import it here and we can use it in the wire. So in the wire statement here, we call this particular function, and then we pass on a parameter with our search key. The search key has a specific syntax here. You notice that it's a string, but it's prefixed with a dollar symbol, which means that it is a reactive property. So what this does, in effect, is that each time we change the value of search key, we will refire the find contact method with the new value of the search key. So if we change the search value, we return a new list of contacts. Now, the @wire is extremely powerful because it allows us to do this reactive search, but it also allows us to directly map the results of this backend call to the contact property. So there's no logic. You don't have to do any call to the fetch API or especially any type of logic to figure out what is the right backend to call. We just have to match this wire function to a particular property here. Then I will not explain all of that, but this is just what helps us to do the matching of the keywords with the function itself. Now, one last thing what we want to see now is how does this all ties together. So we've seen the basic hello component, and then we've seen the wire param. Now, there are a lot of other things that you can explore from running from data service. And one of the things that you have to know is that all of the interactions here are customizable with clicks. So what we saw here is really the basics, but as you go into more complex use cases, you can explore complete objects with specific fields being set to visible for specific users. And when we explore that a bit further, we can go into data service features, which allow us to visualize certain parts of certain records with or not, depending on the context of the user session. That being said, let me now jump back to the slide and conclude. If you want to learn more about Lightning Web Components, we have assembled for you a collection of learning resources, and you can access those learning resources by going to this particular link here. The idea is that these web components can be learned from different angles. You can start by learning web components by using our open source framework, and this will tell you about the structure of web components, the standard, the decorators, all the custom elements, the shadow DOM that we use. Then you'll apply this to the enterprise scale by moving what you have implemented with Lightning Web Component open source to the Salesforce platform. And what this links point you to is a set of customizable and bite-sized learning projects. So if I just go over them, I'll show you a very quick overview of what these do. These are free projects, very simple project, which allow us to learn about Lightning Web Components. So it basically takes 3 hours to do that. And in the first project that you'll run, you'll start to build a web application with Lightning Web Component open source. This will guide you step by step with our online learning platform called Trailhead, and you'll see how to create an application, how to create different components, how to work relationship between the different components. And in the second project that continues after the first project, you'll see how you can convert your existing work into an application which is connecting to the Salesforce backend. So you're still running Lightning Web Component open source inside a standalone application. But this time you're actually connecting and retrieving Salesforce data and bringing it back inside the Salesforce, inside the standalone application. Finally, there's a third project that also takes an hour that allows you to convert your standalone application that's been built with Lightning Web Component open source and port it to the Salesforce platform. And this allows you basically to really reduce the amount of code that you've written and host directly the same standalone app, but on the Salesforce platform. And you'll see, which is very interesting because you'll see that a lot of the boilerplate you had to run and write when you were outside of the platform is eliminated by the things like the Lightning Data Service. You see how this is a great addition. This platform integration is a great addition. All right. With that, I'd like to thank you for your attention, and I'm now going to answer questions if there are any. Thank you. I'll leave you a couple minutes to ask questions. You can use the chat for that, or the questions for that. All right, I can see some questions that are coming. So one of the first question is, which version of Visual Studio Code supports Lightning Web Components? So what we have to understand here is that um, we generally use the most recent version, but you can go back to older versions. And what is important is that you have Visual Studio Code with the right extensions. So there is something called the Salesforce extension pack, which adds the extensions that allow you to do things like remote code deployment or local development on Visual Studio Code. So it's Visual Studio Code plus Salesforce extensions. Let me also show again the previous link. I went a bit fast, so I will just go back to the previous link as someone asked for it. I will paste that as well in the chat box, so if you want to take it, you can go away with it. Let me dump that here. I've added the link to the chat. Oops, no, not to organizers, sorry, to everybody. Let me do that. Here you go. Now, I see other questions here, so let me take that. Another question is, can we use Lightning Web Components in Visualforce pages? All right, so let me bring a bit of context for those of you who do not know what is Visualforce. Salesforce runs a set of different technologies to do front-end or custom components in user interfaces. And we currently have 3 technologies that we support. And historically, we had something called Visualforce. Visualforce is server-side rendered. We then introduced another technology called Aura, or what was originally Lightning Component. And then finally, we have Lightning Web Components. And now the idea with Lightning Web Components is that it's compatible with the 2 previous technologies. So you can run Lightning Web Components inside Visualforce page or inside Lightning pages. Other questions. Can we use Lightning Web Components with jQuery? So yes, you can do that, but it's generally not needed in the sense that jQuery was created at a time where the standards did not provide things like CSS selectors. And now with new web APIs, you can have something like document get query selector, which replaces what jQuery used to do. So it is still possible, but it's also not necessarily a good thing to use jQuery with it. Another question, how do you test your components? So that's something I went a bit fast in the demo. I forgot to show you that, but essentially web components are JavaScript. So we have provided an extension to the popular testing framework called Jest, which is provided by Facebook. And we did an extension to that for Lightning Web Components. And this allows you to do testing on your local machine for Lightning Web Components. You have the whole range of assertions for that. Other questions. There's quite a few here. I'm going to try to select them and make sure I answer them in the most detailed way. Bear with me a second as I read through them. All right, another question. Is there any other UI tool option instead of, by IE tool, I mean IDE, development environment, instead of Visual Studio Code? So the answer to that question is yes. Visual Studio Code is the official IDE that we provide, but you can use also other IDEs that are provided by our partners. So when you want to work, for example, on the Salesforce platform, you can use something else called it's called Illuminated Cloud, for example. So this is something that is subscription based. But Visual Studio Code is free, and I think it's a really good start. It's pretty flexible. And also you can have a lot of plugins on that particular IDE because it's used by a large community. So that's pretty interesting to use. Let's see, other questions. Yep. So back to the Jest testing, there will be another webinar soon on that particular aspect of things. It will be also hosted on CodeMotion. Thank you for reminding me of that. All right, another question. Well, this is pretty specific. Let me try to go for more general things first. Um, so I'm trying to answer the questions that interest the most people. Sorry if I don't pick every single question. Um, all right, that's a good question. Can we use properties that you input in component APIs in CSS? So can we use basically proper CSS properties? So for the moment, we do not allow this. This is a work in progress, I believe. So this is probably gonna come soon on the roadmap. Now, what we do offer is something called expressions that allow us to plug in JavaScript functions to calculate a list of CSS classes that are applied to a particular component, which is right now the way to replace those CSS properties temporarily before we make them available. Um, someone mentioned that the link is not working. I believe it is working. I've just accessed it recently, so maybe it was a problem with copy pasting. Make sure you have copied the full link. Let's see other questions. Yes, is the code samples that I showed available in public Git repos? So yes, that's the whole interest of the sample galleries. When you go to the sample galleries, let me see, where's my window? I'm lost in my windows, sorry. I believe I've just closed that. But if you go to the sample galleries here, when each time you have a component or a little recipe here, there's a link at the bottom showing view sources. When you click on that, this takes you to the Trailhead repository, which contain the GitHub repository, which contains all the source code for all the recipes, and you can see the different files here, which represent all the different recipes. So what you have to do is go on Google and search for Trailhead Sample Gallery. You'll find a list of resources. Let me show you that as I go. So if I go in here and if I search for Trailhead Sample Gallery, just like I did earlier, you'll find the first link, which is our sample galleries. And if you go in here, you'll find the different search. You'll see the different recipes, and each time there's a link to view it on GitHub. Now, the recipe that I showed you, the sample application that I showed you here today was recipes, which is the on-platform version of those recipes. We also have an off-platform version of recipes, which shows you the difference between the Lightning Web Component on-platform and Lightning Web Component off-platform. So you can look at those two things and compare them. And if you want to go and explore a bit more, you can see some more advanced use cases with complex components and more integrations with our platform features. So this is again a sample gallery, which you want to search for. All right, other questions? Why are all the attributes in Lightning Web Components in lowercase? So yes, in Lightning Web Components, we are using standards in terms of naming. So what we have is something called different type of cases. So when we create a component, everything is in lowercase separated with dashes. So if I take a name of a component that is kind of long, like this one, Apex imperative method with complex params, you can see that this is written in camel case. So first letter is in lowercase, and we have capital cases to denote separations of word. But then this is turned into something called kebab case. So this is all lowercase with dashes separating the words when it comes to the custom element in HTML. And you can see that if I open the HTML template, this one, hopefully, yes. You can see that it is transformed into this specific syntax, which is the standard for custom elements. So this is not something that is Salesforce specific. This is something which is imposed by the custom element specification. So all lowercase and words are separated by dashes. That's the way custom elements work. And when we use properties within JavaScript, we also follow this some of the rules, which means that the first letter is generally lowercase and the words are separated with capital letters. Question, is this session getting recorded? Yes, it is. So if you missed the beginning, you can have a look at the recording, which will be published soon on the CodeMotion platform. Other questions? All right. So what is the difference between the base components that are on and off platform? Sorry, not exact. No, let me rephrase that. What is the difference between the base components that are for Lightning and Lightning Web Components? So the difference between those two is fairly small, and if you go and search online for something called the component library, I just use a shortcut I have, you'll find a list of all of these base components, and I show that, and I did show that in one of the slides here. We have a whole range of more than 200 base components that you can use and leverage for your create applications. Now, you can use those with Lightning Web Components, but you can also use the same components with Aura, which is the previous technology, what we called Lightning at first. And so the idea is that at this point, I believe we are almost at parity between what we can do with Aura and Lightning Web Components. There may be a few components which are not deployed on Lightning Web Components, but we're very close to having the same components available in both technologies. I have two questions actually related to something called PubSub. So I did not show that during my demonstration here, but one of the challenges we have when working on complex pages is that you have multiple components on those pages, and these components need to communicate. Now, I did mention that we have something called locker that prevents different components from accessing the entirety of the page or explore what is on the page. So we have a safe way basically to allow communication between components, and this is called PubSub, or Publish Subscribe. In the first version of Lightning Web Component that we released, this was provided by by custom code, which was something temporary, I would say. We have now the ability to get rid of that PubSub temporary code, which was working with events, and we can now replace that with something called the Lightning Messaging Service. This has just been released in our latest release, the winter release. Now, this is called Lightning Messaging Service, or LMS in short, and this is a standard way to create messages that are being exchanged across a page on the client side. And this is more powerful than what we had with PubSub, because PubSub was pretty limited to Lightning Web Components. With Lightning Messaging Service, we now have the ability to exchange information between all three of our component technologies. So you can exchange between Visualforce, LoRa component, and Lightning Web Components. This is pretty powerful. All right. Other questions? Well, I have a question from someone who was working in Angular for the past 5 years and is wondering how long would it take to learn web components from the start. So I think this is a very interesting question, because what we saw in the presentation was that each technology has had its own approach to solving common problems, especially like templating, accessing data, and everything. And Angular is a very, very specific example of that, especially in the days they went for a first implementation, and then they realized that they had not taken the right path, so they created the Angular version 2, and they did a lot of changes. So that's what we had in the past, different frameworks with not necessarily a straight path for safe evolution. With Lightning Web Components, it's very different because what we're using here is only standards, so there's no chance that this kind of scenario will happen with our technology. And if you want to learn it from scratch, it's fairly simple, because if you already know JavaScript, if you know CSS and HTML, this is just what we're leveraging here. So we have provided in the link I shared earlier a set of free projects that really aim to get you started, and it takes about, really for a basic application, you can do that in starting from 1 hour to 3 hours, so it's fairly quick to start. What we also have is, with recipes, a good list of code samples that you can use to create more complex projects. So I think it's something that can go very, very fast. If you're already familiar with JavaScript, which you should be, if you've done Angular, you should be able to pick this up very rapidly. Again, some other questions regarding the recording. Yes, this session is recorded, and you'll be able to watch the recording later on when it's posted on the CodeMotion platform. All right, I'm going to take one last question. Let me make sure it's something that has the most value for everyone. Yeah, very good question. So, do we need to have us to be a Salesforce customer to run these applications? So my answer to that is no. So you don't have to have a subscription to Salesforce to run these applications. So there are actually two types of answers I want to give to that particular question. So first of all, if you just want to explore web components, you can start with web components open source. So that means that you don't even need a Salesforce environment. You can just run that on a standalone machine on your computer with a standalone server. What we're doing here, for example, for a start, is we're allowing you to run a Node.js server that runs on your machine. Then, if you want to explore Lightning Web Components, so this is the on Salesforce platform version, you can create a free account and you can explore that further. And again, if you really want to see all of these different approaches, you should really take a look at the link I gave with the free projects, because you're going to start on your local machine and then move on the Salesforce platform, and you'll see the trade-off, what you gain and what are the things that require specific attention. All right, that was the last question. Thank you again for joining in, and I hope you had a very good time with me and you learned a few things. We'll talk again in the next upcoming webinar, which will be targeted on just testing on the Salesforce platform. Thank you again, and goodbye.